Okay, now we have a situation, two lines. I don't bother labeling the lines, but it's clear where the two lines are. And given that this angle is 5x and this angle is x plus 30 degrees, what are the two angles? Well, we know that we can write an equation, and people that didn't have a whole lot of trouble understanding this, that this angle and this angle add up to 180 degrees, so that we can write an equation, x plus 30 degrees plus 5x equals 180 degrees. We simplify this, and I did mention that if you are having any trouble with the algebra and it doesn't come back to you completely on refresher, section 7.1 of your text is a really good reference for solving linear equations. That's all you need to do this stuff. You just have linear equations, and you should work through section 7.1, which might take an hour. Students usually have a pretty easy time with section 7.1. Okay. Anyhow, we simplify this. First of all, there's no number in front of any of these parentheses, so we can just go through and in this case remove the parentheses. We get x plus 30 degrees plus 5x equals 180 degrees. Now, you don't subtract x from both sides, and you don't subtract x from this side but not this side. You don't subtract x from 5x. You simplify this side, meaning you add x to 5x to get 6x. So this side, there's 5x's here, there's x's, there's 6x's on this side, and then you add 30 degrees. Now, some people wanted to subtract the 30 degrees from both sides, and that wouldn't be harmful. That wouldn't confuse you much. But you want to simplify both sides before you start manipulating them. It's simply less confusing and better structure. Okay? There are things you can do that would lead to confusion and damage your solution. So I say make sure both sides are as simplified as they can be before you start adding and subtracting things. Okay, now 6x plus 30 degrees equals 180 degrees, so we subtract 30 degrees from both sides, giving us 6x equals 150 degrees, and then we divide both sides by 6, giving us x equals 25 degrees. Knowing that x is 25 degrees, our ultimate goal is to find this angle and this angle. Well, if x is 25 degrees, 5x is 125 degrees, and x plus 30 degrees is 55 degrees. Double checking, these add up to 180 degrees, so we're fairly sure we've got a good solution here. Now, a comment. This angle doesn't look like 125 degrees, and this angle doesn't look like 55 degrees. 125 degrees would be an obtuse angle, and 55 degrees would be an acute angle. And that's clearly not the case here. Point is, it doesn't matter how the picture is drawn. If we say that this is 5x and this is x plus 30 degrees, this is our conclusion, this is our conclusion, and we observe that the picture doesn't represent the angles very well. But the picture doesn't really tell us anything. The picture makes it look like this should be an acute angle, this should be an obtuse angle, but our information shows otherwise. Okay. Another situation. You can see the picture here, the letters A through H indicating the various points on this figure. And I say that AF, the line AF, because there's a double arrow, is parallel to the line BE. Well, line AF, that's this line. And of course, it goes in both directions. Since we're talking about the line AF, let's go ahead and just put a couple of arrows on it to indicate that it's a whole line. And the same with this line, and the same is going to be so with this line. So what we're saying is this gives us the information that these two lines are parallel. Again, if you measure them carefully and measure the distance between them at different points, you'll find that they aren't really parallel. This line isn't even all that straight. But the picture is said to represent parallel lines. Just because the lines look parallel doesn't mean that they are parallel unless it's so stated. So here we state that the two lines that kind of look parallel, look like they ought to be, are indeed parallel. Then GD, this line here, is called a transversal of the parallel lines, any line that cuts through the parallel lines. Some people say, well, that's a horizontal line. Well, yeah, I drew it horizontal, but if I'd have drawn it like this, everything would have been equally valid. Okay. Now, we observe that angle GHA and angle ECD are equal. Now, the actual argument for that is, and I don't think I used the terminology over here, but for example, this angle and this angle are equal, and they would be called vertical angles. The same with this angle and this angle. They're equal, and they're called vertical angles, and we observe that vertical angles are always equal. Angle GHA and angle ECD are equal. Well, they look like they ought to be equal. They look about the same, but they're equal. Some people, one person said, well, they're vertical angles. Well, no, not quite. This angle and this angle are vertical angles. So GHA and FAC are vertical angles. And then it's going to turn out that this angle is equal to this angle, so that this angle and this angle really aren't vertical angles, and this angle aren't vertical angles either. So what? Okay, well, I'm looking at ECD and GHA. For a minute I was confused because I'd labeled this angle, but this angle and this angle are equal. They're called alternate exterior angles, and that terminology means, first, alternate, it means one parallel line, the other parallel line. They're alternate parallel lines. And external means outside of the region between the parallel lines, external to the parallel lines. Internal would be between the parallel lines, between here and here. So this angle and this angle are alternate, and they're exterior. So they're alternate exterior angles, and for reasons related to what I said earlier, these angles are equal. Now, that has nothing to do with this angle and this angle, okay? So what can we say about this angle and this angle? Well, this is an exterior angle, this is an interior angle. They're on opposite sides of the transversal. And it turns out that this angle, well, this angle is going to be equal to this angle. And this angle make up the 180-degree angle here. So given this figure, and given that this is a transversal of two parallel lines, we want to solve for x. So what do we know? Well, this plus this is 180 degrees. And people were very quick to see that. Okay, so we write down the equation. We simplify both sides before we start messing with anything. Now, I haven't written out all the intermediate steps here, but we have 3x here and we have 2x here. That makes 5x. And we have minus 10 degrees here and plus 50 degrees here. That makes 40 degrees. So we have 5x plus 40 degrees is 180 degrees. We subtract 40 degrees from both sides. 40 degrees goes away here, and we end up with 140 degrees over here, so that 5x is 140 degrees. And then we divide both sides by 5. We get x equals 28 degrees. And then we would substitute that back in here to get these angles. I didn't do that. I leave that to you, but I'll say that, well, if this is 28 degrees, 2x is 56 degrees, and you add 50 degrees, you have 106 degrees here. So I'll go ahead and fill that in. This should be 106 degrees. And 3x, 3 times 28 is 84 minus 10 is 74. This is 74 degrees. So if I take this and bring it back up here, I get 106 degrees here, 74 degrees here. Of course, that would mean I've got 74 degrees here, and 106 degrees here, and 74 degrees here, and here, and here. I think I already mentioned that. 106 degrees here, 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 and here. Okay.